Is it playing? Okay. All right, guys. So yesterday we learned basic elimination. Today we're going to learn a step forward or more, where sometimes you have to multiply both equations to make the x's or the y's opposites instead of just one. Okay. So again, the steps are to multiply one or both equations so that the x's or y's are opposites, add the equations so that the x's or y's zero themselves out, and then substitute to find the other variable. Okay. Well, if we look at this one, this is actually going to be number 20 on your worksheet. You notice that where none of the numbers are already opposite, so we're going to have to multiply, and we're going to have to multiply both equations, because if I look at this, none of these are factors or multiples of each other, but I can find the lowest multiple of the x or the y to multiply by, if that makes sense. Okay. So if I look at this, I want to deal with the smallest numbers I can because that's just easier. There's multiple ways to do this though, so I'm going to look at my 2 and my 5 here, because I know if I multiply those together, they equal 10. So what I'm going to be looking for is for 10 and negative 10, okay? Or to make those 10 and negative 10. And this is kind of getting into fraction logic, finding the lowest common denominator. It's a similar concept. So in order to make, we're going to make one, we're going to use 10, okay? To make this 10, I need to multiply this by 5. To make this 10, I need to multiply everything by 2. Does that make any sense? Yes, no? Mm-hmm. Joey, can you hear me? Cool. All right.
You're not actually finding anything.
Oh, I gotcha. All right. But I left something out. So this needs to be negative 10, which it will be, because if I multiply a positive times a negative, then it will be a
Positive.
A negative.
Oh, a negative. I thought you
Yeah.
said negative.
Yeah,
I'm
yeah.
sorry.
So let's go ahead and start multiplying. Now, I multiply each term by 5 here and each term by 2, okay? So we go ahead and start doing that. So if I multiply this, I end up with 5 times 2 is 10x. 5 times 8 is 40. 5 times 6 is 30. Okay? The second equation, 2 times negative 5 is going to be negative 10x. 2 times negative 20 is negative 40. And then 2 times negative 15 is negative 30. Seeing something interesting here. So if I add all of these together, they actually all zero themselves out, which is interesting. So so the purpose was to get x to be opposite. So 10 plus negative 10 is 0. 40 plus negative 40 is 0. And then 30 plus negative 30 is 0. When this happens, this means that there are infinite solutions. Okay, because you got a statement of equality here at 0 equals 0. So this is one where there are infinite solutions, because they're the same line. Okay? All right, now let's do one where we get an actual numerical answer. All right, this will be number, let's see here. Let's do number 20. I just did number 20. Never mind. Okay. All right, so let's do number 19. Okay. So we have negative 4x minus 2y equals 14. Wait, what number? This is going to be number 19. And then we have negative 10x plus 7y equals negative 25. So I want to pick one of these to modify, okay? One of the variables, that is. So between 4 and 10, the least common multiple is 20 because 4 times 5 is 20, 2 times 2 is 20. Or I could do 2 and 7, which is 14. 2 times 7 is 14, 7 times 2 is 14. Which one do we want to do?
4x.
You want to do the 4x, you want to eliminate the x instead of the y?
Or 2y. I meant the.
You want to do the y's. Okay,
Yeah.
that's fine. So in order to make them opposites, we have to multiply both equations. Okay? So in order to make this, so we're trying to make it into 14, right? So we have to multiply, 14 is our magic number, all right? So to multiply the top one to get y to be 14, we have to multiply it by positive 7. To get this one to be positive 14, we have to multiply it by positive 2. So this, it's already negative 2, so if we multiply it by 7, it'll be negative 14. This is already positive, so if we multiply it by 2, it'll be positive 14, and they'll cancel. Okay, so let's go ahead and start doing this. So I do 7 times negative 4x is going to be negative 28x. And again, we're eliminating y here. You can eliminate either variable. So then I have 7 times negative 2 is going to be negative 14y. And then 7 times 14, let me do that in my head. 7 times 10 is 70, 7 times 4 is 28, 28 plus 70 is 98. So that's going to be 98. And then I've got 2 times negative 10 is going to be negative 20. X. 2 times positive 7 is going to be plus 14y. And then 2 times negative 25 is going to be negative 50. Now my second step is to add these two things together, right? So I'm going to add them together. So I'm adding my x's, I'm adding my y's, I'm adding my constants. So negative 28 plus negative 20 is going to be negative 48, x. And then this is 0. Negative 14 plus 14 is 0, right? Its sole purpose is to zero that out. And then 98 plus negative 50 is going to be 48. So now I have negative 48x equals 48. It is a one-step equation now to solve for x, so divide through by negative 48. 48 divided by 48 is going to be 1. In this case, negative 1. X equals negative 1. Now the last step is to take this and substitute it back into one of the original equations and solve for the other variable. So if x is negative 1, I put negative 1 for x in one of the equations. I'll just do this first one. So then I do negative 4 times negative 1, because x is negative 1, I substitute it in, minus 2y equals 14.
What is this? Oh, okay.
Shh. All right, negative 4 times negative 1 is going to be positive 4, minus 2y equals 14. And now I'm going to, Stephanie, I'm filming. So then I subtract 4 from both sides, and then minus 2y equals 10. Divide through by negative 2, then y equals negative 5. So my coordinate, my answer to this is negative 1, negative 5. Let me write it in a different color. And again, the whole purpose of this is to find the coordinate. This is a coordinate where these two lines cross each other on a graph. That's the whole purpose of a system of equations. All right, we hit pause. Pause video.